In this video, I'm going to go through a worked example related to some of the learning outcomes belonging to radioactivity. If you haven't had a chance to go through those slides and take some notes on radioactivity, I wouldn't really do this one yet unless you just wanted to kind of see what this what a question would look like belonging to some of this physics. But if you have had a chance to already go through some of the radioactivity stuff, go ahead and try your hand at this question here. This is a question that comes from ACE Physics Syllabus Code 9702, Paper 11 from May-June 2011. It's question 38, and it reads, the first artificial radioactive substance was made by bombarding aluminum, or aluminium, and they give us this 2713 Al, with alpha particles. This produced an unstable isotope of phosphorus 3015P. What was the byproduct of this reaction? Usually we'd read this as phosphorus 30. Only things with 15 positive charges in their nuclei are phosphorus. That's sort of what defines the chemical species. So like we'd call this like aluminum 27. This question gives us an opportunity to remind ourselves of the learning outcome, represent nuclides using their nucleon and proton numbers. And so this is a nuclide symbol. That's the nucleon number, and that's the proton number. And so aluminum, here this isotope of aluminum has 27 total nucleons. 13 of them are positively charged, or protons, right? And all the rest are neutrons. And so this number is neutrons plus protons. That's just the protons. Likewise here for phosphorus. And if you look at a periodic table, you'll see that, there's always a letter P there. You're at the 15th spot, and, aluminum occupies the 13th, because, again, that's the way that we sort of define what element it is by the amount of positive charge. The important thing to keep in mind for this type of question is the conservation of mass energy, and in particular, really mass. Everything is conserved. We got to keep track of everything here, and so we do have to remind ourselves what is alpha radiation. And so this question is also a chance to look at the learning outcome, show an understanding of the nature and properties of alpha, beta, and gamma radiations. This one more specific to alpha radiation, obviously. All right, so let's go ahead and write this all out. All right, so we're bombarding aluminum with alpha particles. There's a really interesting history of like the transuranic elements and how fission was discovered, and Lisa Meitner, Otto Frisch, and relationship to the Manhattan Project. I'll leave it to you all to research that on your own. Very fascinating, though. With alpha particles, so remember an alpha particle is a helium nucleus, and so that's one way to think about an alpha particle right there, right? It's 2 protons, that's what makes it helium, with 2 neutrons, and it's just the nucleus, right? So there's no electrons. It's not a neutral helium atom. It is just the nucleus of helium. That's what an alpha particle is. And they said they got an unstable isotope of phosphorus, so they get a phosphorus like that. And it's unstable, so it's probably going to decay into other things. But just looking at this step of the reaction, we can maybe figure out what's kind of missing here. So we've got the 13 protons in aluminum, and then 2 of the positive charges from the helium crashed into it, and it's stuck there, and we got a phosphorus. Okay, so far so good there on the protons. But up here we notice that 27 plus 4 would give us 31. But this is an isotope that only has 30 nucleons. So there's 30, total nucleons in the nucleus, 15 protons, 15 neutrons, and so if we started with 31, we've got to end with 31. We didn't destroy this, and so we already have accounted for the positive charges, the protons, and so what was the byproduct of this reaction? Well, that's sort of like, the product, one of the products. And so the other one must be D, a neutron, right? We've got that other nucleon in there that must be a neutron. So choice D.